Hi everyone, my name is AMAMILO CYNTHIA. I'm a student of Fountain School and I am in SS1. I'm going to talk more about standard form and the relationship between standard form and indices. But before I go to get to that, let me tell you about the founder of standard form. Standard form was invented by a Persian mathematician in the 9th century named Muhammad al-Khwarizmi. He is often credited as the inventor of standard form. Scientists use standard form when working at the speed of light and the distance between galaxies, which are enormous. The seam of bacteria or atom in standard form are referred to as they are so tiny. Standard form is also called in scientific notation. Now let's look at the guidelines and formula of our standard form. The guidelines of standard form are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the formula is a times 10 raised to the power of n. Our n here is the integer, our 10 is the base, and our a is the number from 0 to 9. That is between 0 to 9. Now let's look at some examples of the standard form. Let's have 4, 3, 5. Now, this standard form are given don't have a point. So, whenever you are giving a number like this without a point, just get it in the back of your head that the point is at the front of the last number. But when you are given a point, you have to just move either backwards or forward. Now let's move our point to a number that when the point is in between, we can find the end of the number here. When we move our point like this, we can't find 43 here, so we have to still move it backward. And when we move it like this, 4, we can find 4 here, so our point will be here. So it will be 4.35 times your base over the integer. And integer is number you move the point either backward or forward. So our integer will be 1, 2. And whenever you are moving your point backward, it will be +2, but the plus will be invisible. But when you are moving it forward, it will be minus whatever number you get. Now let's go to another example. Now if you have 2, 3, 4.1. Our point is in between a number, and this number cannot be found in our guideline. So we have to move it to a number that we can be able to find in our guideline. So we have to move it like this. We can't find 23 here, so we have to move it backward again. And when we move it backward, it will be 2, and we can find 2 here. So it will be 2.341 times our base times all over the integer, which is how many times we move it? 1, 2, which is 2. Now let's look at some example of the minus sign. If we have something like 0.00561, this is a different example. Now since our point is in between 0, so we have to move it to one of the number here. And when we are moving it forward, it will be minus. When we move 1, 2, 3, we can find 5 here. So our point will be in between 5 and 6. So it will be 5.61 times your base raised to the power of the integer. Your integer will be minus because you are moving it forward. So it will be 1, 2, 3, which is minus 3. So this is some example in standard form. Now let's move to something interesting, which is an extra relationship between standard form and indices. According to the law of indices 1 and 2, it says that whenever you're having a times is equals to plus, and whenever you're having a division, it also means subtraction. So this is the guideline going to enable us solve this relationship between standard form and indices. Now let's solve this example. We have Example 1. 4, 3, 2, 1 times 1, 2, 2, 1. And just remember at this example we have here that whenever you don't have a point, your point will be here. Now let's move our point for 4, 1, 2, 3. 4.321 times 10 is about 1, 2, 3 times 1, 2, 3, 1.221 times 10 is about 1, 2, 3. So you bring these two together and you bring these two together, which have 4.321 times 1.221 times 10 raised to the power 3 times 10 raised to the power 3. So if you do 4.321 times 1.221, we have 5.27591 times. According to indices, whenever you're having you're having the two base, you need to pick one of the base. Pick one of the base. Then, whenever like our guideline here, times also needs plus. So we're going to plus the two integer together, which is 3 plus 3 will give you 6. And this is our answer. Now let's move to example 2. We have number like 0.001,234 divided by 0.00423. Now let's solve our second example. Have 1, 2, 3. So it will be 1.234 times 10 raised to the power 1, 2, 3. There's the minus, we're moving it forward. Minus 3 divided by, for the division sign, 1, 2, 3. 4.23 times 10 raised to the power minus 3. Bring this 2 and bring this 2. 1.234 divided by 4.23 divided by 1, 10 raised to the power 3 minus 10 raised to the power 3. Now our answer for this is 0.29172 times 10 raised to the power minus 3 minus 2. 0.29172 times 10. Minus and minus will give you plus, so minus 3 plus 3. 0.29172 times 10 minus 3 plus 3 will give you 0. The answer will be 0. But this is our final answer because you still have a 0 like this. So you have to move it backward. When you move it backward, 2.9172 times 10 raised to the power minus 1 times 10 raised to the power 0, which will give you 2.91